Hey there, fourth graders. So we are continuing working on equivalent fractions. And today we're going to learn a strategy that you can use always to find equivalent fractions, whether you have manipulatives in front of you or not. Okay, so before we do that, I want us to make some observations. Right here I've represented some equivalent fractions. I have 1/3, 2/6, 3/9, and 4/12. All right. It's a little bit squonky there, but they're all equivalent. All right, so I have these equivalent fractions listed here. I want us to see what do we notice. And I want you to pay careful attention to the denominators and patterns that you might notice with the denominators. You did talk about patterns last semester and how to identify number patterns, and I want you to kind of think back to that. Think back to last semester when you were looking at identifying number patterns. Okay, now as I'm looking at it, I'm looking at just the denominators right now. My denominators go 3, 6, 9, 12. 3, 6, 9, 12. That sounds a whole lot like skip counting by threes to me. Does it sound like skip counting by threes to you? Yeah, it does. So it sounds like I'm listing the multiples of 3. Okay, well, multiples multiply up, up, up. When multiples multiply. So maybe I can use multiplication to help me find equivalent fractions, right? Because I'm listing multiples of 3. Well, let me test this out. I just want to see. I'm going to pick a number that's not a multiple of 3 and see if it can fit in here with my thirds. I'm going to pick 4. Okay, well, 1/4 is smaller. 2/4 is bigger. Okay, let me pick another one. I'm going to pick tenths. All right, let's see here. 1/10, 2/10, 3/10. Oh, it's close. 3/10 is close, but it's not quite the same. 4/10 is too big. No. So it's looking like if the denominator is not a multiple of 3, the fraction is not equivalent. So that leads me to believe I can use multiplication to help me figure this out. Well, let's think about this, okay? I'm skip counting by threes. 3 times 1 is 3, 1/3. 3 times 2 is 6, 2/6. 3 times 3 is 9, 3/9. 3 times 4 is 12, 4/12. That is very interesting. Now I want us to keep that in mind as we look at this strategy. All right, I'm trying to keep my little fraction strips organized as I'm making all of these videos here. All righty, so let me get my paper. All right, now on here I have a definition, and this is a definition that you actually learned back in 3rd grade, but it is something that we did review in 4th grade as well. And this is the identity property of multiplication. Identity, the way I always like to think of it is like identity is like who you are, right? That's your identity. So the identity property of multiplication helps to represent who that number is. Okay, well, anytime I multiply a number by 1, that number stays who it is, right? It stays itself. That's a really cool trick with multiplication. So I could take any number I want, and if I multiply it by 1, then it's going to stay the same. Equivalent fractions are all about representing the same amount in different ways. Okay, so now let's think about this. Let me go back to 1/3. If I have 2/6, is there a way I can multiply 1/3 by 1 and get 2/6? And I'll leave that there for you. Is there a way I can multiply 1/3 by 1 and get 2/6? I want you to think about that. The answer is yes. There is a way, because we talked about in the very first video, and if you skipped over that video because it didn't go with the lesson, go back and watch the first video. We talked about there are fractions that equal 1. They have the same numerator and denominator. So if I multiply 1/3 by 2 over 2, which is the same thing as multiplying 1/3 by 1, I would get 2/6, because when we multiply fractions, we just multiply straight across. It's very easy. So 1 times 2 is 2, 3 times 2 is 6. Oh, well, let's try and find another fraction that's equivalent to 1/3. All right, this time I'm going to pick 3 over 3. Right? As long as the numerator and denominator are the same, that fraction equals 1. So 1 times 3 is 3. 3 times 3 is 9. 2, 6, 3 ninths. This is what we were just looking at. What about 4 over 4? Oops, I said 4 and I wrote 4. If I multiply by 4 over 4, 1 times 4 is 4. 3 times 4 is 12. So we can find an equivalent fraction for any fraction by multiplying it by a fraction that equals 1. A little chant that I like to remember, and this is my fraction bar: what you do to the top, you do to the bottom. What you do to the bottom, you do to the top. You need to do the same thing to the numerator and the denominator to end up with an equivalent fraction. And you're going to be using equivalent fractions a lot moving forward. So you really need to understand this strategy. You're going to be using equivalent fractions to help you compare fractions. You're going to be using equivalent fractions to help you with adding and subtracting fractions, specifically in 5th grade. In 4th grade, we're not going to use equivalent fractions as much with adding and subtracting fractions. We will a little tiny bit. We're going to kind of touch on it. But 5th grade, you do that a lot, and that's a big part of your 5th grade curriculum. All right, we use equivalent fractions all the time. So you want to make sure that you understand equivalent fractions. You could even use equivalent fractions in real life. I'm thinking of, sometimes when I'm cooking, certain measuring cups are dirty, right? Have you guys ever helped cook and that's the case? If a measuring cup is dirty, but if I use an equivalent fraction, like let's say I need half a cup of milk, but my half a cup is dirty, I could wash it, or I could do 2/4 cups of milk, because 2/4 is equivalent to 1/2. Okay, so that's another example. So let's continue looking at this and how we're using the identity property of multiplication to help us. Let's say I need to find an equivalent fraction to 2/5. Okay, I could pull out my fraction strips and do that. But I could also multiply 2/5 by a fraction equal to 1. You don't have to put your fraction equal to 1 in a box. I just do to help me keep this in mind. I'm just remembering these are fractions equal to 1. All right? Now, Mrs. Long, does it matter what numbers I put here? Yes and no. Yes, in the sense that they have to be the same. The numerator and the denominator has to be the same, or else the fraction's not equal to 1. No, in the sense I can make up anything. If I wanted to do 7, as long as I do 7 both times, it works. So 2 times 7 is 14, 5 times 7 is 35. So I know 2/5 is equivalent to 14/35. Now, I would recommend, if it's not telling you like the numerator or the denominator has to be a certain thing, pick easy numbers to multiply by, guys. Don't make it hard, right? So if it's just saying find 2 equivalent fractions to 1/3, well, it's really easy to multiply by 2. It's really easy to multiply by 3. It's really easy to multiply by 5, right? Pick numbers that are easy to multiply by. Sometimes, though, you might see something that looks like this. So let's say I have 2/5, and I want to figure out what it's equivalent to, and I know that the denominator has to be a 15, because you will see this as well. Well, I'm going to multiply, right? And I have to think. Now I'm going to think about my multiplication facts. I told you those are going to come back to you. I'm going to think about my multiplication facts. 2 times what equals 15? 2 times what equals 15? 5, or sorry, not 2. It's 5. I'm pointing to the 5, and I'm skip counting by 5s, but I'm saying 2. 5 times what equals 15? Sorry, guys. Clearly, I need some more code 0 here. 5, 10, 15. 5 times 3 equals 15. What I do to the bottom, I do to the top, because 3/3 is the same thing as 1. All right? 2 times 3 is 6. So I know that the 6 would go there. All right? So I know 2/5 is the same thing as 6/15. All right? So that's how we're going to use multiplication to help us to find equivalent fractions. And this is going to be your most common strategy for finding equivalent fractions. So this is going to be something that I want you to be super duper familiar with. Now I want to ask you a question. I'm going to write it up here, and I'm going to write it in a different color because this is a completely different kind of question. Let's say I'm trying to find an equivalent fraction. I want to find an equivalent fraction to 3/4. And this is what I did. I want you to think, what did I do wrong? Now you should have little alarm bells going off in your head. If you don't, now you for sure should have little alarm bells going off in your head. What did I do wrong? Is that fraction equal to 1? It's not. My numerator and denominator are not the same. 1 whole and 1/2 are not the same amount. Okay? So this is not an equivalent fraction. 1/4, or sorry, 3/4 and 3/8 are not equivalent to one another. They're not the same. I could even test it out. I could pull 3 of my 4ths, right? And 3 of my 8ths, and they're not going to be the same. And you know that because the 8ths are smaller. Remember, if the pieces are smaller, it takes more of them. So I am wrong because I did not multiply by a fraction equal to 1. I always have to have that same numerator and denominator when I'm multiplying to find equivalent fractions. All right, so in our next video, we're going to keep working with a very similar strategy, but we can also do the opposite of multiplication and divide, and that would be called simplifying fractions. So we're going to go over that in the next video, but this should help you with your lesson, and this is a strategy I really, really want you guys to focus in on and become super, super familiar with this. Lots and lots and lots of practice with this, because I am just going to tell you right now, you have to know how to do this. You absolutely have to know how to do this, okay? So focus on this, work really hard on this, and I'll see you in the next video. Bye, guys.